My name is Paul Bontempo. I'm joined by Nicholas Derby. This is our final project for Datacenter Scale Computing, a distributed linguistic analysis as a service. An overview of our project goals and motivations. I'll describe the components of our system, talk about our testing and debugging process, and then Nick will provide the video demonstration of our working system in action. Our motivation for this project was that Nick and I are both linguistic researchers and NLP researchers, and so syntactic and semantic parsing are both necessary preprocessing steps for a lot of research pipelines and data analysis pipelines for other fields as well, like law and computational social science. So we wanted to provide a system that would allow users, even if they don't have as much of a technical background or programming experience, to be able to use these processes or analysis tools on their data, even if they don't have, for example, like the um, computational resources to run them locally on a large data set. So we wanted to cloud host them and streamline the process of accessing them. Our system basically has the job submission from the user, which gets sent over to a API for text chunking. Then that gets distributed, those chunks get distributed as jobs to all of the workers. The workers perform the language processing. The final worker aggregates all the results, posts it to the Firestore database, and then the user can retrieve the analyzed data from the get endpoint. So the user uses a post request, they specify the actual input data, the analysis type they want to do, so either syntactic or semantic, and the chunking type that they want to use, so either like by sentence, by document, etc. The text chunking gets done by the API server using the Spacey Python package. And in the case of semantic analysis, it preserves one sentence of context on either side because that's necessary for that type of analysis. Then the API server publishes each chunk to a pub sub queue, and the load balancer maps those chunks as jobs to all the workers. GKE autoscales the worker virtual machine instances according to the length of the queue. Each worker analyzes each job using the Spacey and then the Allen NLP packages for the actual analysis. And then the final worker, once the length of the number of process chunks is the total number of input chunks, final worker combines all of them and reduces any redundant data that overlapped. And the user can get the final output data from the Firestore job status page via URL. So here's our diagram, which basically describes what I just explained, where we, for testing, we used 2 API servers and 3 worker nodes. But of course, like I mentioned, the number of worker nodes would scale up or down depending on traffic dynamically. And these were our development and debugging steps. We developed everything locally first, of course, while we were designing the system, and we used local emulators for the Firestore database and the PubSub queue. We used Google Cloud Platform Docker image for local testing, and we ran the API as a local Docker image. We had a lot of trouble Dockerizing the image of the worker node, so we ended up using a virtual environment and just ran the worker script locally during testing before we resolved that later on. um, and once we had all the components working locally on our small test set, we deployed to the Kubernetes engine and debugged the deployment YAMLs as necessary after that. So now Nick will provide the project demo.
Now I will walk you through a quick demo of our project. I've already gotten all of the resources spun up on Google Cloud, but just to show you how you could do that yourself, the first thing you would do is run make setup. This spins up all of the Google Cloud resources, including the Kubernetes cluster, Firestore, PubSub, etc. Then you can run make build, and as long as you have Docker active on your computer, this will allow you to build the images for the worker and API, as well as push those images. And then lastly, once everything's built and pushed, you can run make deploy, and this will deploy those images to the Kubernetes cluster. Since I'm already deployed, I can run make status, and this will check up on the health of our cluster. You can see here we have our 5 pods running. We have 2 API pods and 3 worker pods. And you can see also we have the external IP of our API, which will allow us to interact with it. So I'm just going to show you a sample job here. We do this using the analyze endpoint of our API, and our document in this case is just a simple 3-sentence text. We're sending this off to perform both semantic and syntactic analysis, and we're going to chunk this by sentence. So the API will actually split this document up into its 3 sentences and send those off individually to the workers. So I'm going to go ahead and submit that. You can see then we get our job ID here, and we can see that it's been chunked into 3 chunks, which is what we expect, given this has 3 sentences. We can then check up on the status of our job using the status endpoint of our API. So I'm just going to go ahead and paste in this new job ID. And you can see now we have the status completed. This is a pretty short document, so it took basically no time at all. And then you can also see the download URL, and this is what we can use to actually see the output of this job. We can view this using another curl command, just with our link like so. And now you can see the output of the job. You can see for each sentence of our input document, we have a syntactic analysis in CONNELU format here. So any downstream task involving constituency parsing, syntactic analysis, etc., you can use that. And then we also have the output of our semantic role labeler. So you can see all of the verbs have been labeled and extracted along with their respective arguments. So yeah, that concludes the demo, and thank you very much for your attention.